Hey guys, this is Mrs. Koffel. I'm one of the 8th grade science teachers here at Irons. Some of you may have me for class, some of you may not, but I'm going to talk to you today about rotation and revolution. So I've got a base here just to kind of get you started on your notes. So I'm going to show you a little bit what this looks like. So I'm going to have one side here that has the earth on it. I'm also going to have one side that's going to have the sun. So if you want to take a moment and pause as we get started, then you can do that. And then that way, if you want, you kind of have a base, and then we can just add the notes in. So you get to choose how you want, because at any time you can start, stop, pause, whatever you need to do. You can also rewind. So feel free to just do whatever you need to set your stuff up. So what we're going to do is we are going to start with this side. So this part right here, you can tell we have a little compass. I am not an artist, so this is the best I could do for Earth. And we have a little clock here, and then we just have some text boxes that we're going to be writing in today. So I'm going to go ahead and get us started. So on this side, I want you to put at the top, I want you to put rotation. We're just going to write rotation. All right, rotation. And what I mean by that is this is how the earth spins round and round to make us day and night. Okay, so we're going to have a little day and night action. And so if you want, you can make this as artistic as you want or as little as you want. So I'm just going to draw a little sun over here. And then I'm also going to draw a little moon. And like I said, you can fill stuff in. You can make it as colorful as you want. You don't have to make anything colorful at all. I'm just going to do this real quick and call it a day. Okay, so we have our little moon and we have our little sun. Okay, this is what we're talking about. We're talking about this 24-hour day period. So over on this side, I want you to just put one day, because this is all we're talking about. When we have a rotation, it's one day. That's it. 24 hours. Now I want you to notice something. Right here we have our Earth's axis. And I want you to notice that it's tilted at a 23.5 degree angle. So I'm just going to put in here, in this little box, sorry, I'm using the wrong side, tilted axis, 23.5 degrees. Now if you notice, I have this north, south, east, and west, because I want you to notice that this axis is pointing at a little bit more north. Okay, so we're just going to come in here and we're going to write the Earth's axis always points to the Polaris. Now, some of you also probably know this as AKA the North Star. So that's what we're talking about, the North Star. So this guy, this axis right here, points to the North Star. Now I want you to also notice something else. When we rotate counterclockwise. This looks like this little number. Okay, if we're doing it over here on this big guy, it's going to look like this. When we continue that around, okay? Now when I say counterclockwise, I want to make sure that you write that in. Counterclockwise. Because what I want you to notice is here with this clock at the bottom, if you're looking at a normal clock, notice what direction it goes. This goes clockwise. So how we read a clock is clockwise. So this way is counterclockwise. It is not how we read a clock. This guy, this direction. So counterclockwise would actually be going in the opposite direction, which is what this is doing right here. It's going in that opposite direction. So with this rotation, we have 24 hours, which gives us day and night. Now, common sense would tell us that the daytime, we would face the sun. It would also tell us that at nighttime, we are away from the sun. So that's it. When we're talking about rotation, we're just talking about that 1 day, 24-hour period that gives us day and night, okay? Paying attention that we have a tilted axis at that 23.5 degrees, and that we are running counterclockwise. So we're going to take it now to this side, okay? So we're going to take it to this side, and we're going to write revolution. All right, revolution is 1 year. So notice, rotation is 1 day. Revolution is 1 year. So, once again, if we look at this guy, this revolution right here, I want you to put the word seasons. Okay, so we have day and night over here, and we have seasons for revolution. I also just want you to make sure that we remember, even though we're having revolution, we are still pointing to Polaris, which is the North Star. So I want you to look. Here's our sun, and here's our Earth rotating, and I want you to notice counterclockwise. So on any one of those sections, you can put counterclockwise. Okay, and it's easier to see when you're looking at it more two-dimensional than when I was doing it over here. Counterclockwise, okay, is going this way. But if you're looking at a clock, if you're reading a clock, remember, it's going this way. So that's one good way to remember. You can even look up at the clock in class and go, which way is the hand moving? The Earth is moving in the opposite direction than that. Okay, so you should never have to forget that. So down here in this little text box, we're almost done. Okay, just remember, we're taking 1 year. And if you want to break that down, that's 365.2 0.25 days. So it's a little bit longer than just that 365. All right, so what I want you to do now is we're going to flip your page over, and you're going to use a half a page, okay? I did not get creative with this side and decorate it or anything. We don't have too many notes to put on here, but what I really want to talk about is I just want to reiterate a few things, okay? So when our sun is hitting the earth, it hits it with indirect and direct light. So on this top line, if you look here, we're going to put indirect light. Because if you look how the sun is kind of hitting more of the edges, okay? It's not hitting straight on. It is still getting sunlight, obviously, but we're not hitting it directly. So this is going to give us some cooler weather. So you can think of this as, okay, this might be in the winter time, right? When we get hit in these indirect. So this one is also indirect light, because we're not hitting straight on. So we're still getting that cooler temperature. Now, when the sun is directly hitting us, full force, and I want you to think about something, where would that be hitting? If you were looking at a globe or a map and you're looking at this guy right now, it would be hitting along the equator. So this direct light that hits along the equator. Okay? And this gives us warmer weather. I don't want you to forget that this is our axis, which is tilted, remember, at 23.5 degrees. And something that goes along with what we're talking about is the reason that we receive different amounts of lights at different times of the year is because our Earth is curved, okay? We do not have a flat Earth. So I want you to remember the Earth is curved. And this causes parts of the Earth to receive different amounts of light. If you look at right now, it's getting darker earlier, right? It's completely different than how it was 2 months ago. We're receiving different parts, different amounts of light right now because our Earth is revolving around the sun, and we're getting more of that indirect light than the direct light. And that comes to our last thing that I want to show you. Seasons happen because of the tilt of the Earth. If we didn't have this tilt and the revolving, we would never have different seasons because we would have the same amount of light hitting all the time. So as you move forward, as you see more of seasons, and we'll be doing more seasons work obviously, please refer back to this foldable. It's very important. If you have any questions, please contact your teachers. We are here to help you. I hope this was pretty clear for you, and you guys have a great day. Thanks for listening.